Welcome to the math record. In this video, we'll be learning how to find the derivatives with multiplication, division, and something called chaining. So first, we're going to find the derivative of functions multiplied to each other. So we're going to use something called the product rule, which basically says that if we have a function which is made out of two functions multiplied to each other, so y is f of x times g of x, then the derivative of that function, so the derivative of y, is going to be the derivative of the first one multiplied by the second plus the first one multiplied by the derivative of our second. Or you could just have the first one stay the same, multiplied by the derivative of our second, plus the derivative of our first one multiplied by our second. Because this is generally just the same thing. This is this, and this one's this. So they both calculate the same thing. It's just in different order. It doesn't really matter what order you choose. Both ways are fine. So let's try an example. So let's say f of x is equal to x squared plus 2x plus 3 multiplied by x plus 4. So the derivative of this. So the derivative of our first one is derivative of x squared is 2x. Derivative of 2x is 2. And the derivative of 3 is 0, so that's nothing. And then keep the second one the same. And then we keep the first one the same now. And now we have to find the derivative of our second one. So derivative of x is 1. And derivative of 4 is 0, so that's nothing. So anything multiplied to 1 is just itself, so we don't need that. So this simplifies down to just 2x plus 2 times x plus 4 plus x squared plus 2x plus 3. Oops, let's make that a little bit shorter. 2x plus 3. Okay, so let's say we want to find the derivative at x equals 1. So when it's 1. So plug that into our equation. So 2 times 1 is 2, plus another 2 is 4. And plug 1 in here. 1 plus 4, that is 5. Plus x squared, which is 1 squared, which is 1. 2 times 1 is 2. And add a 3. So that is 20, 21, 23, and 26. So that means the slope, or the derivative, at x equals 1 is 26. Okay. Now let's learn something called the chain rule before we actually do something called the quotient rule, which works with division. So chain rules deal with composite functions, which are functions inside functions. So let's say y is now f of g of x. Now we took the derivative of this. We have the derivative of our function. Keep whatever's inside the same, and then we take the derivative of what's inside. So a way to understand this is basically you're going to take the derivative of whatever you have so far, and then you're going to work from outside to in. So you're going to work from derivative outside, derivative inside, and then you're going to keep going down if there's more chaining that you need to do. So let's just use a simple one with just a one chain. So we could say f of x is equal to 2, 5x plus 3 squared. So take the derivative of this. So 2 times your power, which is 2, is 4. So 2 times 2 is 4. And then 5x plus 3, 2 minus 1 is 1. So you just leave this the same. So we took the derivative of the outside, and this we need a chain inside, but that's inside the parentheses. So 5x plus 3, the derivative of that is going to be 5x. The derivative is 5, and derivative of 3 is 0. So 5 plus 0 is just 5. So you can simplify this down to 20 times 5x plus 3. Okay, so that's our general form for our derivative for f of x on this one. Now let's try something with two chains. So let's say f of x is equal to 2, 5, parentheses, 3x inside, and then we're going to square it. plus 1, and then we're going to square that. So derivative of this. So our outside parentheses is this. So 2 times our exponent, which is 2. So 2 times 2 is 4. So we have 5. Keep whatever's inside. 2 minus 1 is 1. So we could just leave that multiplied. So now we have to find the derivative inside that parentheses. So the derivative of 5 times 3x power 2. So 5 times our exponent, that's 10. Keep whatever's inside, so that's 3x. So 2 minus 1 is 1. So that's the same thing, so it doesn't really matter. And then the derivative of plus 1 is just 0 because that's a constant. And then finally, we have one more parentheses inside. We have our 3x. So we need to chain our 3x. So the derivative of 3x is 3. So overall, our chain rule gives us the derivative 4 times 5 times 3x parentheses squared plus 1 times, uh, this is just in parentheses, so 10 times 3 times this 3, that's got to be 90x. And you can simplify that even more by 4 times 90 is 360, so that's 360x times 5 parentheses 3x squared plus 1. But you could just leave it like this because it's already long enough. So if we now want to find out how to do division, which is the quotient rule, so we have y is now equal to f of x divided by g of x. What we could do instead is we could think about this as f of x times g of x to the power of negative 1, right? So this is just like a product rule because the power to negative 1 means just a reciprocal. So this is the same thing. Now we take the derivative of this. We just use the product rule. So the derivative of the first one times the regular of our second. So that's g of x to the power of negative 1 plus, keep the first one the same, times the derivative of our second one. So we have negative 1 using our power rule. So put the constant down, and then we got subtract 1, so g of x. So negative 1 minus 1 is negative 2. And remember, this is a function inside of a function because this is just a regular reciprocal, but we have a g of x inside that reciprocal. So basically, we had to use the chain rule. So the derivative of g of x. So this simplifies down to, if you want to get rid of the negative exponents, the derivative of x divided by g of x plus, this has negative f of x times our g of x uh, divided by our, multiplied by our derivative of g of x, derivative of g, and then divided by g of x squared. So we could combine this fraction down into by multiplying both of this by g of x, g of x. So g of x times g of x gives us g of x squared like this. And then we have g of x times the derivative of f minus, right, minus f of x times the derivative of g of x. So it's really similar to what we did with our product rule, where we have a derivative of one thing multiplied by the regular of this other, and then we switch places for those. But instead, now we had to divide by the bottom equation, so g of x squared. It's now in the square version. So this is a lot to remember. So basically, all I usually do is that I convert it to this, to our product rule, and then we just chain it. So let's try to use an example. So let's say we have a, I don't know, let's say f of x is equal to 2x plus 1 divided by 3x plus 2. Okay, so pretty simple. So let's convert it to our product rule. So that's 2x plus 1 times 3x plus 2 to the power of negative 1. Now taking the derivative of this, the derivative of our first one, derivative of 2x is 2. Derivative of 1 is nothing, so we just leave it as 2. multiply by whatever's left over, 3x plus 2 to the power negative 1, plus, actually put on the bottom, plus, keep the first one the same, so 2x plus 1 now. Now do the derivative of the second one, derivative with a negative 1, and then keep whatever's inside, 3x plus 2, negative 1 minus 1 is negative 2, and then multiply by the derivative of what's inside. So derivative of 3x is 3, derivative of 2 is 0, so 3 plus 0 is 3, so we can just leave it by itself. So this simplifies down to a 2, so moving it back to the reciprocal, that's 3x plus 2 plus 3 times this negative 1 makes negative 3, and then we have 2x plus 1 in the numerator divided by 3x plus 2 squared on the denominator. 3x plus 2 squared, right? Because it's negative, so it goes down. And this is going to be our formula for our derivative for this function now. And that's basically it. Well, that basically covers everything for this video. In the next video, I'll be covering exponential derivatives. Well, thanks for watching.